In this video, I'll be doing a detailed solution to the maths question you see on the screen here. It's from the Cambridge A-Level exams from 2024, paper 2.2 or paper 2.3. They're actually the same paper. If you're looking for a different question from one of those papers, check out my description below. It should have a link to a playlist there. I'll be doing all this on a whiteboard, hopefully just like you're used to your teacher doing. But remember, we are on YouTube, so take advantage, pause, rewind, or even watch at a different speed. If you do like this video or any of my videos, I would greatly appreciate subscribe, a like, a share, or even a super thanks. In question 6, they give us this image of a curve with the equation y is equal natural log 2x plus 1 divided by x plus 3. And for part A, they simply ask us to find an expression for the derivative. Looks scary that, but it's actually really not too bad. We just need to remember to use the quotient rule. Remember, this is some function divided by some other function. And we're given the formula that in our formula table. It's just, let's say it's the bottom multiplied by the derivative of the top, take away the top multiplied by the derivative of bottom divided by the bottom squared. And so we just split this into two different parts, both of which we're able to differentiate. Let me just use my notes a little bit. Actually, no, I should be fine. So the derivative of this, let's write it up here. We'll need a bit of room. It is quite messy. Bottom row, leave it alone, x plus 3. Multiply that by the top row, the derivative of the top row. What's the derivative of a natural log? Derivative of natural log is just 1 divided by whatever it was, x plus 1. And then this is a complex function. We need to use the chain rule a bit. So we need to multiply by the derivative of what was in here. Let's multiply by 2. Let's just put it up here. Okay, then we take away, leave the top row alone, natural log 2x plus 1, and multiply this by the derivative of the bottom row. Derivative of bottom row is just 1, so we're pretty much done there. Then we divide everything by the bottom row squared. That's x plus 3 squared, and I think that should be fine. There's no great way to cancel things down. I guess this cancels into one of these, but that'd end up splitting the equation out. They just ask for an expression. That's an expression, and it's not that obvious to make it either, so you should be fine giving that as your answer. Okay, for part B, they give us this equation here and basically ask us to find this equation. It's one of those cases where we're going to need this for the next part or the next two parts. So they'd like you to find it, but if you fail, at least you still have it. So basically find this sort of equation. And sorry, I should have said that this equation comes from the fact that the point M, this point here, is a maximum. So this equation satisfies the x coordinate of this point. So you should be thinking about point M, you should be thinking about the maximum as the derivative equals 0. Now, this is a big mess of an equation they got us found in part A. But the great thing is, what happens when this equals 0? Let me write it again here. dy dx equals 0. Well, the great thing is, so yeah, let me just put it up here, equals 0. The great thing is we can multiply both sides by this bottom row, and it just disappears. The left side multiplied by this, it cancels. The right side, anything multiplied by 0 is 0. So that's gone. And well, yeah, that's it. That'll just give us, let me write this guy here, x plus 3 multiplied by 2 over 2x plus 1. This guy can now just move over to 0. So it just equals natural log 2x plus 1. Okay, so that's got us a much more manageable equation. But still, we want it to look like this. I would have just multiplied both sides by this and got x on its own here, but that's not going to look like this, unfortunately. So it is helpful to take a clue from this. They want x plus 3 on the top, and they want natural log on the bottom. We have x plus 3. We have that same natural log here. So that x plus 3 is already on the top. If I just move natural log over this side, I will get x plus 3 divided by natural log 2x plus 1. And we'll move these guys over this way. When you divide both sides by natural log, you'll leave a 1 here. So we can divide both sides by 2 and multiply both sides by this. So we get 2x plus 1 over 2. That's looking very close to this. That's x plus 3 over that, x plus 3 over that. I guess we should switch these around and let's divide the 2 in. 2, well, let's write that again. 2 goes into 2x, x times, 2 goes into a half times. That's pretty much the same. Let's just move the half over and write it out again. That's x. Again, we'll write it inverted. X is equal to this side. X plus 3 over natural log 2x plus 1. And this half will take away both sides, minus the half, which is exactly what they don't care. I wrote fraction instead of a decimal. That's exactly what they wanted for part B. Now at this point, this should be looking familiar. It's a question asked pretty much every year. You end up with something like this, x equals. We're going to be doing an iterative formula. And also very common for part C, they usually first of all ask you to confirm the answers between 2 points. In this case, they ask us to confirm the answers between 2.5 and 3. A couple of ways to do it, but the way I mostly like to do it is I like to put 2.5 into for the left side, 2.5 in for the right side. Put 3 in for the left side, 3 in for the right side. If you find one is bigger than the other on the left, let me draw that here. So what we have here on the left side is y equals x. And on the right side, I don't know what it looks like, but let's just say it looks something like, sorry, should only touch it once, maybe off to infinity it touches it again. We have something like this. And the point is, where is there a solution is where it crosses. So what they're getting us to do is they're getting us to check 2.5. And at 2.5, hopefully we should find one of them is above the other. I may have drawn it the wrong way around. And on the other side, at 3, they'll have switched places. The straight line is on the bottom and the curve's on the top. Here, the straight line's on the top, the curve's on the bottom. That's what I'm about to show over here by putting in the values for x and putting in the values for x plus 3 over natural log 2x plus 1. Hopefully that was clear. So I'm putting in both these numbers. What I want to find here is, well, let's put a 2.5 in for x. It's very easy. 2.5. 3 in for x. It's 3. What I want to find here is a number above or below this, and then I want the opposite here, and that will show me the answers between here. So I simply put 2.5 into this formula on my calculator, and I get out 2.5696. So this one's above, so my drawing was correct. The curve is above the line here. When I put 3 into this equation, I get out 2.5834. It's now below. 3 is bigger than this. 2.5 is smaller than this. 3 is bigger than this. They've switched places on me. So the answer must be somewhere in between. So like if somebody's above something and then they're below it, they must have crossed it at some point. That's all we're getting at there. This little table here, it will be enough to get you full marks. As I think I already said, this is a very common type of question. We end up with a function like this and we end up turning it into an iterative formula just by adding a couple of letters in. If I write this function again, how we do this, well let me rewrite it over here. How we do this, we say this x out on its own is our new guess. We call that n plus 1, the next number in the series. And all the x's on the right hand side is our old guess. Natural log 2 times xn plus 1. What that means is we guess up one answer. I always call it x0. Usually you'll see x0. Sometimes you might see x1. So I make a guess. And that guess can be anything. Although in the previous part they told us the answer was between 2.5 and 3. So my first guess will be 2.75. Feel free to guess anything else. I don't think it matters for this question. Although sometimes you can get caught in loops, but I think they probably picked a question that you can't. Anyway, you make a guess and an answer, and we use this formula here x1, this formula here, the next number is equal to the previous number plus 3 over natural log 2 times the previous number plus 1. And that'll give you a better guess. So that's all we do here. And we stay guessing until our answer converges. Our answer will start looking the same the more we go, because we'll be getting a better answer each time. Another way to say that would be just, well, it's not a correct thing to say, but it might help you think about it, is if we do this a few times, we'll get closer to the real answer. Well, that is the correct thing to say, but how many times we need to do it, I'll talk about in a few moments. Okay, so my first guess was 2.75. So my second guess will be 2.75 plus 3 divided by natural log of 2 times 2.75, plus 1. And if you put all that into a calculator, you get 2.57191. They asked for your answer to be 6 significant figures, and they want your final answer to be 4 significant figures. So I'm going to write them all as 6 and as 4. 2 would be the 4 significant figures. And we know we're at the right answer when you get 2 answers the same in a row of these 4 ones. Okay, and you just do that again. x2 is equal, you put your new guess in here. There is a quicker way to do it. I'm not sure where my calculator is. There is a quicker way to do it by learning to use your calculator a bit better. You put your first guess in and press equals. That'll save in your calculator, this is an answer. Then you put this whole function in, so it's answer plus 3, natural log 2 times answer plus 1. Press equals again and you'll get this. And what's good about doing that way is your calculator then remembers the previous answer, which is this, and the previous equation, which is this. So every time you press equals, it's just going to put the new answer in, and it'll save you a little bit of work. In this case, you only actually have to do 3 times, so it's not too bad. So yeah, you're putting in 2.57191 back into this, and if you do all that correctly, you should find 2.56917, or to 4 significant figures, 2.569. Continue, do it again. Again, put this new answer back into this equation, and you'll get 2.56917. Actually, yeah, you'll get the same answer. I'll explain why in a moment. Usually in this question, you'd have to do this 5 or 6 times to converge on the right answer to the 4 decimal places. In this case, it goes a lot quicker because natural logs and exponentials are just really powerful. They move quite fast. Usually you'd be dealing with something like a x squared or an x cubed, which does converge. It gets big really fast, but not nearly as fast as exponentials do, or well, logs are the opposite, but you'll still converge quite fast in this case. So your 2 answers are the same, so that's close enough. On my calculator, they were the same to 6 places, but they weren't the same to 8 or 9. I pressed my equals another couple of times, and I think at x, the 5th guess, it was as good as my calculator could do. If I stayed pressing equals, it wasn't getting any closer. Okay, that's how you do question 6. And like I said, that question comes up pretty much every year. Guaranteed good few marks. Learn how to do them. I would say it's one of the easiest questions in an exam for this reason. Most students don't have to understand everything they're doing in this question. It's just the same the same method repeated over and over. In other questions, if you don't understand everything, it's difficult to get 100%. In this question, I think you could probably get 100% most times without understanding everything that's going on. Okay, if you have any follow-up questions, let me know in the comments. I'll do my best to get back to you. Thanks for watching. Have a great day.